Okay. Uh, so yeah. As I was explaining functions, we do have this is the agenda for today, like functions, types of functions that we're going to discuss on, and what are the arguments and parameters that we want to that we want to understand when we are creating the functions. And I was explaining how we can use function in real time, what are the advantages of the functions, the main purpose of the functions that we use for the code reusability, which means we can't repeat the same code 100 times, right? So in those cases, we can create a function that can call that function 100 times in those cases, which means we write a logic, and we call that logic in the app in n number of times. Modularity, where we split that up problems into small into small portion by using kind of a divide and conquer technique. And we create a functions for each small problem, and we create a more modularity for better readability. In terms of readability, whenever we are creating a functions, we need to have some proper comments or proper documentation. We call it as a doc strings, which means when you are working on in real time projects, right, you have to collaborate with your team members, right? So from the data engineers or software engineers, from the testing team, which means whenever you create a functions, please make sure that you pass certain commands, certain comments, and certain some description to their function. And maintainability, always check this your function is giving expected output or not, which means whenever we are doing any project, right, we will have some test cases, unit test case, and integration testing, where what we do is we call this function, we will have inputs and we will have outputs. So when we call this function, we'll pass those inputs and we will have the expected outputs. Then we will match those outputs. So when outputs are matching, which means a function is working well. If outputs are not matching, which means we need to update the logic, or we need to fix something in the code. And as you can see on here, so this is a simple structure of functions where we're gonna have some inputs, and we're gonna pass those inputs to some rules that we're gonna define, and we will have the expected output. And if I go to the next slide, as I was explaining previously, Python has some inbuilt functions. If you look at some of the examples here, whenever we want to print something, right, we use print. And whenever we want to do count, we use length. And we want to see the type of that particular data, we use type. And whenever we want to take some inputs from the user, then we use input command. So these are the some built-in functions in Python, which are used for some particular purpose, right? So again, we can't create we can't use remember I was explaining this in the first session. So we do have some keywords in Python. We cannot use those keywords as a variable name, right? In the same way, we cannot create functions based on these names. So whenever you are creating the functions, please keep remember that those names that you're going to define should not overlap with these already inbuilt functions. You see here one of the good examples, I took it online. So when we want to calculate the square root of 4, right? So we know square root of 4, which means we need to multiply, right? So this is my function name, and this is my parameter, and I am passing this information to that one particular block of code. Remember that that's a block of code where it has some rules, certain conditions based on the business problem that we are solving, and we will have expected output. Like that, you will have built-in functions, and you will see some inbuilt functions. So as I was explaining about functions, so we need to follow some structure whenever you are creating any functions, right? So whenever you are creating the functions, it always start with def. So we need to start writing def, and we need to start creating the function name. You see here that this def is my keyword to define a function, and this is my function name, calculate underscore area. And by opening the parentheses, uh, I am passing the parameters here, and you see colon, and this is my business logic or whatever logic that we want to specify here, and we are returning something, right? So this is the simple structure of the function. And you can see here, here we have, these are the steps we need to keep always remember whenever we are creating any function. So we start by defining the function by using the def keyword, and we need to start writing the function name. It has to be, it can be any, it can be snake case, it can be camel case, doesn't matter, but here I have took it example of snake case. And remember, this function name should be unique. Let's say, for example, you are writing 100 functions, right? When you are creating the 100 functions, those functions names should be unique. Those function names should not be same. And parameters, which means which means again, when as I was explaining the previous lesson, whenever you are creating the functions, functions will have some expected inputs and expected output, right? So those we call those are parameters, and we specify these parameters inside this parenthesis. And this doc string is tells us, okay, what it does. Now you see this comment here. So returns circle area, which means okay, whenever I'm using this function, first thing I'll see this, okay, this function does something, what it does, return circle area, okay. Okay, it returns circle area, okay. And here we have some formula, right? So in those cases, doc strings are very important, because as I said, as I mentioned previously, when you are working on any project, right, your teammates, your colleagues, they should be able to understand what you have written, and what the function it does, and what are the expected inputs, what are the expected output from this function, right? Always remember, when you are creating the function, the function should have some readability. And at the end, you will have written statement, right? You see here, uh, here we have written the output called area. So these are simple functions, right? So and then we need to discuss about the arguments and parameters from the function. So you have seen in the before slide, we are creating the functions by using def and the the function name, and here we are passing some parameters, right? So we need to remember there are certain conditions or certain rules we must follow whenever we are passing any parenthesis, sorry, any parameters. You see here, I'm assume that we have the function called greet, and it takes two parameters. One it will say message, and another one is name, whatever. Okay, you see here allies and hi. Okay, so these positions are very important. What happens, we're gonna see some of the examples when we are doing it practically. So these positional arguments of these parameters are very important, which means, so when the function expects the first parameter is allies, or the second parameter is high. So when you start swapping these values, when you specify high as the first parameter, allies as the second parameters, your whole function will return error, right? Because whenever you are creating a functions, you will have some inputs, right? Okay, first, this is my first input, this is my second input. So based on that, you always need to remember, okay, these positional parameters are very important. Then if you look at here, and here we can specify the name. Okay, you see here, uh, again we have function called greet, and we are passing one value called message, which is hi, and name Bob. Okay, so like that, in the we can pass names to the parameter as well. And also default values, you see here, here what I'm trying to do here, here we have function called greet again, and we are calling one parameter called name, and message equal to hello. So you see here, this is the default value. Even though if I don't specify the message value, it will call from this place. Then arbitrary inputs, which means sometimes we don't know how many parameters that we want to enter, right? So in those cases, we can start calling these args and the keywords by using these stars. We can specify arbitrary input variables. And you can see here, This is one more way of structure of the function. We have this key def keyword, and the function name that we want to specify, and what are the parameters that we are specifying. So you see here, this function my sum is expecting two parameters, a comma b. Okay, and what is my logic here? Return a plus b. Okay, so you see here, this is my function, right? So I'm calling this function my sum. So it expects two inputs, right? As parameters, right? We specify two parameters, right? One is 10, another one is 20. So we call these as arguments. So the difference between parameters and arguments here is, parameters we call whenever you are creating the function. So arguments are called whenever you are calling that function. So you see here 10 and 20. So when we run this command, you will see the output of 30, which means what's the logic that we have specified here is a plus b, right? So 10 plus 20, you will see expected output as 30. This is a simple structure of function in the coding part. Now these arguments and parameters are very important. The positional arguments, when we create a function with certain parameters, and when you are calling that function, and you need to maintain that positional parameters, otherwise your entire business logic, or the your data logic will get failed. Then, as we talked about inbuilt functions, right? Like length, max, sum, all these are inbuilt functions. At same time, we can create our own functions. Okay, what is the purpose of creating our own functions here? We need to understand here, some built-in functions are good for us to do something, right? But when we are working on the real data problems, right, you will face some situations where you need to have some own functions based on your data logic, or based on your problem statement, or based on your business logic. So that you need to create your own function, and you need to customize your own function as per your business problem, and you need to follow some naming convention as per this. At same time, same thing I have mentioned here, definition, which means what tasks I want to do. Okay, I am creating, get a top 100 users function, right? Okay, this is the function I want to call. I want to create as user defined function, and this is my function name. And what it does is, it does some task, some logic I need to specify in the function. And then customization, okay, proper naming I have to give, proper doc string, or proper comments I need to specify, so that some others will understand from my team what I have written. And you see here again, we specify as a def, and the function name and parameters, and we will have the statement is nothing but what the logic that we want to build there. And we will have written expression here. So this is a simple way of constructing the function. Then we have one more type of function called lambda functions, right? So user defined functions are good for us to create the functions based on the data problem, or based on the business logic that we are trying to solve, based on the requirements. And sometimes we'll be having some situations where we're going to create one line functions, right? So in those cases, we use these lambda functions. Lambda functions are there for us to create one line functions, which means, you see here, you see this example, whenever you want to create any lambda function, so we start importing lambda, and we need to specify the parameters. For example, if you look at this example here, I'm creating a new one function called square, right? Square equal to, so it takes one argument, okay, called x, colon, and x star x, which means square of this value, right? So it's basically, let's say for example, if you specify 5 here, 5 into 5, 25. When we specify 4 here, 4 into 4, 16, like that. So whenever we want to write inline functions, which means very short functions, are inline functions, so in those cases we can use lambda. And then we have some the purpose of this lambda function here is to uh, one second. Yeah. So here the condition is the main disadvantage of this lambda function. What we have here is, so we cannot use this lambda function for big complex logics or multiple statements, right? So be careful that whenever you are using the lambda functions, so you should specify uh, exactly what we want to write as an inline command. So, and we do have another type of function called recursion function, which means recursion is nothing but uh, whenever you are calling the same function itself, you will see some situations when for the Python recursion functions, whenever you are calling the function same again in the same function, in those cases we call that's as a recursion, Python recursion functions. So these are the main types we have. Again, as a data science point of view or machine learning point of view, you will be mostly using lambda function or normal traditional functions that we have seen previously. This kind of recursion functions you might see very rare. So that's the reason I am not much explaining the recursion function at the moment now. In the future classes, when we start to doing any machine learning project or when we start doing any analytical project, then we'll start more focusing on the recursion side. So then, sorry for this. Then we do have the local versus global variable concept. I will explain that during the code part, what it does, what is local variable, what is a global variable. Why can't we call a local variable as global variable? I will explain all those during the code explanation. And whenever this is the one more important slide that we want to discuss here, right? So what the best practices, which means what is the best way to create any function. So one is single responsibility, which means whenever we are creating the function, okay, it has some meaning, right? It has some purpose. So it has to handle the multiple tasks. It has to create some sub functions. So in those cases, whenever we are creating any functions, we need to keep remember that it has some modularity whenever into some sub problems, and keep it short, right? So you remember again, whenever creating any functions, do not create 100 lines, do not create 150 lines, do not create 200 lines. So keep it short and simple. And if that is exceeding more than 200 lines or exceeding more than 500 lines, okay, create one more function, call that function in another function. You can do that easy. You can do that easily. And descriptive naming, as I said, whenever you're creating the function name should be unique. Let's say, for example, you have 100 functions. Those 100 function names should be unique. You cannot use same function name for another function. In those cases, it will override, and it will have you will see some faces with the parameters and arguments as well. Then the second part, the final one is documentation. Documentation is very important whenever you are creating the functions. When you are working in a team, when you write a function, someone should be able to read your function by using your comments, by using your doc strings. As you can see here, one of the best example. See here we have function, and here we have two functions. The same thing. You see here def f p return this. You see here which is the best way. You see here we have def and the function name, and we have price rate, right? So and you see here I have we have specified okay what it does, which means this is called, I mean, this is more kind of a documentation, the doc string, and it return some value. So in those cases, always whenever you are creating the function, please be remember that we just need to pass required parameters and what are the expected inputs and expected outputs for that particular function with the proper commenting. So now let's get into the practicals. Yeah. So now we're gonna see some practical parts using functions. As you can see here we do have some don't worry about this code. uh, this code, just try to create some functionalities here to for better understanding what are the inbuilt functions we have, what it does based on the category. You see here some of the math functions, some of the basic input and output function. You see print, we have seen previously, right? We have seen in previous classes to print something, we use this. And we have input to take inputs from the user. We have open whenever we want to create, whenever we want to open any file, we use open. And some of the mathematical operators, some of the data types operators, which means all these functions we already have Python inbuilt. So we need to remember all this whenever get any situations. Let's say for example, we have a list, I want to find some of the values, so then we will call this sum function. Or when if you want to find the minimum value, we use this for some functions. Okay, so it's good that we need to remember all these functions from the Python what we have. And whenever we have in a situation, we can call these functions at any point of time, and we can use them. Let's see some of the examples with those functions. And here you see here, we have a list, and we have a list of values. And here we have max value, and here we have min value. So we already know max will return max value, min will return minimum value, right? So if I run this command, you see here we got 89 and 12. Remember when yesterday when we were working with the loops, right? We created a block of code. It will take list of values, it will try to return the max value. See, but that what we have written, but Python has already inbuilt function called max and min. We can simply use this max and min whenever we want to find these kind of scenarios. And you see we have one more function, math function called sum. When we use this, we're going to get the sum of values from the list, which means all these are inbuilt functions. So as I was explaining previously, the parameters are very important, right? So whenever we create a function, we define some parameters, right? So whenever we are calling a functions, that particular function will expect us to pass same kind of arguments. So now I am here, I'm intentionally using function, and I'm passing list. So when I run this, you see here unsupported types, which means it's throwing some error, which means the sum function will expect numerical values, but here I have passed string values. So that's very important. So whenever you create a function, the function should have some parameters. You need to pass those parameter exactly whenever you are passing any arguments. And you can do one thing, if you want to understand what kind of information for each function has, then you can use this help command, and you can pass that parameter name called help. Then you can simply see the documentation. So this is, you see here, this is the documentation, very wonderful documentation, right, from the Python. So like that, again, you whenever you're creating any functions, you need to simply specify what are the functions you have, what are the parameters you have, what those parameters will do, what is the expected output, like that. So let's see some user defined function. So you see here, we have seen this structure during the presentation part, and we start with doing def, and I'm creating a new function called add. So basically it takes two parameters, a comma b, and colon, it return something. What does it return? A plus b. So basically what I'm trying to do here is I'm creating a two parameters, and I'm doing a addition between those two parameters. And you see again here, I'm calling that function, I'm storing it a variable called result. I am just printing that. Okay. So you see here we got output 12. So what happens if I specify three parameters here? Let's try that. So let's say for example, whenever we are creating a function, we have specified two parameters, right? But whenever I'm calling the function, I am passing one more argument. Okay, you see here, add this add function will only take two positional argument, but we have given three. That's the reason. So documentation is very important. Okay, whenever we are creating a function, and this positional argument also very important. And one more simple example for us to understand the functions you see here. So I want to check age. So what I am doing here is I'm creating a keyword here, def space check underscore age is my function name. What it does is it will take one argument, one parameter called age. So inside that logic, what I'm trying to do here is if age greater than or equal to 18, return adult, or else return minor. So when I execute this command, you see here I'm getting the output adult because I have passed value 20. Like that, you can create a function and you can pass your logic like this, and you will have some expected returns from your logic, and you can return those by using this. And here one more business problem we have. You see here the difference between all these functions, and based on the situation you need to specify your logic. And here we have the problem statement. What I am trying to solve here is I am trying to take temperature as a parameter, and I am trying to convert into conversion type. So should I convert into Celsius to Fahrenheit or Fahrenheit to Celsius? So, which means how many parameters I need here? I need two parameters. I need temperature and I need conversion type, right? So, uh, scale to convert. So, you see here the documentation is well written. So what it does, convert the temperature between Celsius and Fahrenheit. So what are the arguments that it expect? It expect temperature, it expect the conversion type. Okay, temperature, the value to convert, the conversion type either C to F or F to C. And what it returns is convert a temperature or some error message. What error message here is, if you look at here, basically this function will expect two kind of parameters, right? One is either Celsius to Fahrenheit or Fahrenheit to Celsius. But when we specify some other keyword like a K to C or F to C, or sorry, Z to C, which means that is not expected in our language, right? In our function, right? So it will throw error that okay, the converted the past parameter, the conversion type is invalid. We're gonna see with some examples. So okay, so what's our logic here? First I need to check, okay, what kind of conversion type I am trying to do. Okay, so if conversion type equal to Celsius to Fahrenheit, so return this, which means do this task. Else if conversion type equal to Fahrenheit to Celsius, okay, perform this task. Is what I'm trying to do here is based on the conversion type, I have specified some logical conditions here. Okay, if conversion type equal to this, return this. We want to return this value. If conversion type equal to this, do this. If not, if you get any conversion type apart from C to F or F to C, raise this error. So when I start running this command, you see here for the first one, I got a good output without any issues because I have passed what the way the function expects those arguments. And even for the second input, you see here, same thing is happening. But for the third input, you see here, I intentionally passed K to C because so I want to tell that here is how the function works. So even whenever you pass any wrong argument, your function will throw error, or if your function will give false returns. Like that, you can create a function in this way. You can pass n number of parameters based on your business logic, and you can have expected outputs. Again, whenever you again when I said n number of parameters is don't pass like 100 parameters or 200 parameters. Okay, whenever you are passing some creating some parameters here, those should make sense for your problem statement. If you want to pass 100 parameters, better to break down your function, break down those parameters into different function, and call those functions into another function is the best way to perform your task. So again, we have another statement, another function here we have. So it helps us to check whether the string is palindrome or what does the palindrome means here is, so either way the string should be same, which means if you see here we have the keyword called race car, right? So from front to back the indexing, right? So both all the characters are same, R, R, A, A, C, C, E. So in those cases we call that particular string as a palindrome. So again, I want to create a function here. Okay, so what I'm trying to do here is I'm start calling it as a def, because whenever we specify this, Python starts thinking as, okay, he's going to create a function. Okay, this is his function name. Okay, he has only one parameter. So you see here, so this is my logic. Okay, this is the logic I want to do. Okay, I'm trying to clean my function. So initially what I'm trying to do here is I'm converting into lowercase if I'm just checking whether this string has null values or not. Okay, so then I'm doing just comparison, right? Clean versus, why we perform this clean colon colon minus one to reverse the string, right? So what it does is you will have the original string and you will have the reverse string. So basically it will perform the comparison between the each character from this starting position and this backward position. It will return whether the particular string is no, palindrome or not. And again, you see here the structure of the function. Okay, so I have specified what that particular function will does, and what are the arguments that I'm going to pass, right? Here I have only one passed, sorry, here I have only passed only one parameter called text. So whenever you are calling that function, it will expect only one argument. And when I execute this command, you see here, you see my function is not returning any false state, it's not returning any error. But so let's say, for example, let's pass one more parameter, some more arguments. Okay, 1 to 1 comma uh, 3 to 3, okay, as a string. Okay, so whenever we are defining this function, how many parameters we specified? Only one, right? So whenever you are calling that particular function, it will expect only one argument, right? So here you see I'm intentionally creating, I'm passing two arguments. And when you see here again, the error what we have seen previously, it's showing saying same thing, right? So is palindrome takes only one positional argument, but we have given two. So like that, whenever you are creating the function, please remember that the positional of those parameters and arguments are very important. And here we have one more example problem statement given. So basically, they are giving us a text called any text, and we need to count how many vowels are there. And the logic is same that what we have seen yesterday's class. So basically, we're gonna iterate to each character if the character is matching to the vowels, and we start doing the count. So if I run this, you see here for hello world program. Okay, so there are only one A, one E, one I, sorry, zero I, two O, like that. See, you see the total count vowels that are present in that particular uh, this hello world variable. So these are, you see the structure here. Okay, here we are specifying this def keyword. This is my function name, and I'm passing one parameter, and this is my logic that I want to solve, and this is my return from that logic. And whenever I'm calling that function, I'm specifying the name of the function, and I'm calling the argument here, right? So like that you can do you can create so many number of functions, and each function have different set of inputs and outputs, and you can start running in your application. So this is one more another problem statement we have. So basically, what we are trying to do here is we want to create a function that checks the strength of our password, right? So in a real, this is a real time scenario example, right? Let's say, for example, you are trying to create an account, right? So initially, you start what you do, you start doing sign up, right? So whenever you are doing the sign up, So it will check the password strength. So if you specify very simple password, it will not allow you to create that password, right? So it has some rules, certain conditions. We must follow those. Then only system will let us to create the password matching their conditions. In the same way, same thing I am trying to do here. You see here, I am creating a function called check password. So here what I'm trying to do here is I'm creating a variable called score and initialize it as 0. And the first thing what I'm trying to do here is, so I generally people start entering some easy passwords, right? Easy names. Okay, password 123456 admin. So if user enter this, okay, what I'm trying to do here is if user enter any of these passwords, so then I am giving score as -2, which means if pass, what I'm trying to do here is I specified it as a dictionary. And if I first thing what I'm trying to do here is I am converting all these passwords as a lower character to better check for the readability. And if those passwords in this scenario, then what I'm trying to do here is I am assigning the negative index. Then in the next step, what I'm trying to do here is I'm creating the length. Okay, for example, I have entered 10 letters as part of my password. So the length will be 10. Based on that, you see here, I am assigning the score. If length less than 8, I am assigning score as 0. If length less than 10, the score will be 2. If length less than 12, score will be 3. It's just a simple incremental update for this. Else score 4, which means you see here, so if I pass those conditions without any issues, my score will be high, right? So which means my length of the password should be very big number. Okay, it can be 15, we can enter 15 no, characters. It's very good, very big password. So in those cases, you see the score is increasing. And also what I'm trying to do here is, and also I'm checking whether that password has any uppercase or lowercase. So sometimes you see whenever you are logging into any system, sign upping into any system, you will have certain conditions, right? You should have a length of 18 characters or 10 characters. You should have one uppercase, you should have one lowercase, and you should have some special characters, and you should have some numbers, right? In the same thing I'm doing it here. I'm just checking whether that particular password has uppercase or not, whether the particular has lowercase or not, does it contains any digit numbers or not, and you see here has special characters included or not. So you see here this simply nothing but it returns this how many whether true it or whether true or false. Again, what I'm trying to do here is if uppercase present, increase score by 2. If lowercase present, increase score by 1. You see here like that. This is my logic to create a very strong password. So if all conditions are matched and if my score is greater than 9, then only my system will return as either this particular user can sign up or not. So if I start executing this function, you see here the for first one it's returned as false. Okay, which means this particular password did not match the criteria what we have specified in the function, right? That's the reason it did not allow you to create that particular function. But for the second one, you see here, this is very good. This is a big password, hard to guess, that not part of this common passwords, right? So your function returns true, which means you can use this password to create your account. Like that, you can you again see this is kind of a reusability, right? I can use, let's say for example, assume that we don't have the concept of functions, right? So when we want to start writing this function, you see here you need to write these many lines of code every time for the every user. So that's the reason when these functions concepts are very important for the code reusability, and we can call these functions for n number of users. Let's say, for example, tomorrow, 1 million users are coming to your website. and you can call this function to for them to make sure to have a very strong password. So like that we can by using the functions we can have strong reusability and in anywhere in the application. And again, one more problem statement here we have, please try to go through this problem statement. This is very simple. What I am trying to do here is same like previous one. So let's say if I assume that when you have any e-commerce website, so they want to create a score for your profile, right? So in those cases, based on some successful orders, failed logins, whether I'm verified email or not, phone verified or not, total spends, any suspicious activity, right? So let's say for example you have one credit card application, company, and you have users data, right? So in those cases, you want to score your users based on certain conditions. If they number of orders greater than 20, or if they have any failed logins, or if they verified their email ID or not, if they verified the phone number or not, the total spent is greater than XYZ number, and any suspicious activity they have they done in the past, like that. We can have certain criteria as a parameters here. You see here all these I have specified as a parameters, and this is my logic that I want to perform. And here I will have some score. What it does is it will return that particular score, whether this is true or false. When I start executing this here, you see here, for this user, it can be trusted, and for another user it returned as a false, like that. You see here, based on this problem scenario, we created a function based on a certain rules, certain parameters, and we have passed this all the parameters as arguments. So what happens if you here, let's say for example, I'm intentionally, what I'm trying to do it here, I am rechanging the position of this uh, position of arguments. Let's use failed logins here, and let's use email verified here. I know somehow I did here, right? You see here, keyword argument repeated, email verified, which means it's throwing error. So whenever, because this is not way the function is expecting. This is expecting something else. No, we need to look the documentation. Okay, if I'm a person, I'll come to here. Okay, here I didn't mention any documentation. This is the example, right? That's the reason. So if again, if that function throws error, right? So let's say for example, Pardu have created this, and some other person wants to use this function, but he passed the arguments in a wrong way. So again, he'll come to the function part and he'll look for the documentation and position of the each parameter and what are the expected outputs, right? So like that, whenever you're creating a function, please make sure that you pass you pass a particular documentation or particular commenting based on what that function will do. Then we'll be talking about this local and global variables. So what does this local and global variables does is, whenever you are creating a functions, you try to use you try to create so many number of variables. In this example, to calculate the total, what I'm trying to do here is I'm taking the two parameters, right? Price, quantity. So I'm creating a new variable called total, and it's just a multiplication of price and quantity. So when I run this, I'll not get any issues, because this is the correct way to pass these parameters and argument. But if you see here, remember I created this total variable inside function, not outside the function. So when I call this, you see here, name total is not defined because we cannot access any local variable. Local variable is nothing but when you create any function, sorry, when you create any variable inside a function, so that can be called as local variable, and you cannot access your local variable outside the function. That's the reason it threw error, name total is not defined. But if you look at this example, here we have function, it help us to add tax based on the amount, right? So this is a formula, amount plus amount into tax rate. And you see here, for 100 I got tax rate 120. It's very good, it is working, no issues. And when I run this command, right, you see here, it did not throw any error because this tax rate I did not define in the function, I defined outside the function, which means I can call this tax rate anywhere in my code, anywhere in my app. So there's a simple difference between local and global variable is local variables are help us to uh, call inside the function, and you cannot access those variables outside the function. So when it comes to global variables we can access anywhere. We can access the inside the function, we can access the outside the function, and we can specify the variable like global. We do have one keyword called global like this. Let me show you that example here. So like this, we can specify, okay, this is a global variable that I want to use. Okay, we can specify like this whenever you are creating the functions. Then we talked about lambda, right? Lambda functions are very one-line functions, I would say, and small anonymous function, which means whenever you want to create a simple functions which has only one line, right? By using the lambda functions, you cannot create a complex logic that what we have seen in the previously, right? Using lambda functions, we cannot perform all these tasks, but we can perform one time, single line, operations. Let's say, for example, here I'm creating a new function called discount price. I'm enabling it as a lambda. It expect one argument called price. And then what I'm trying to do here is after this colon, this is my operation, price into 0.9. So when I run this, you see here, I'm applying some discount for this, this price variable. So like that, we can create the lambda functions by using this keyword. Again, it depends on the scenario, depends on the problem statement that we are solving. When we want to create a simple one-line function, or simple any or two parameters, we can simply use lambda functions. But whenever we are creating any complex whenever we're dealing with any complex problem, in those cases I would not recommend to use lambda functions. We better to use the functions what we have discussed previously, the structure of the function. And this is one more examples I have. I want to find the fraud monitoring, so which means if any payment is greater than 500, so I want to get those transactions. Again, I'm what I'm trying to do here is I'm just, again, this is one more inbuilt function called filter. What it does is, based on this condition, so lambda, what are the parameter I am passing here? X. It only takes one parameter. If it is greater than 500, from where? From these transactions. It will only filter those values. So like this, based on the scenarios, based on the conditions, based on the problem statement, you can define different types of functions. If it is simple function, maybe one line function, go for lambda. If it is very big function that we want to do, uh, it's better to go for the traditional way to create a function, calling the parameters, calling the arguments, creating the doc string, updating the comments, so that whenever someone is reading your function, they should able to easily understand what you are trying to solve there. So that's all from the function. Any questions?
No.
One second.